So today we're going to use all the different 4 laws of logic. You need to make sure that you can read a sentence or a couple of sentences and use a law of logic to make some sort of conclusion. So this first one says, if I eat dinner with Michael, then I will not eat pizza. The second sentence says, I will eat pizza. So the conclusion must be that I will not eat dinner with Michael. And then the question is, well, what law of logic was used here? And this was modus tollens. Second one, if I don't work out with the team, I will not play on Saturday. I don't work out with the team. So the conclusion is I will not play on Saturday. Law of logic used here should be detachment. Third one, if I practice the violin, I will perform with the orchestra. If I perform with the orchestra, my friend will be jealous. The conclusion here then should be, if I practice violin, my friend will be jealous. And then that one here should be the chain rule. And then last, Joe is not a student or he is not a teacher. Joe is a student, therefore Joe is not a teacher. And then this one then becomes a disjunctive inference. So these are the 4 laws of logic that you need to know. It definitely makes sense, I'm sure, as you're reading sentences, but can you transfer that into the 2-column proofs that we're doing? Here's the first proof. When you take a look at all of your givens and your proof statement, if you want to play that backwards game, you're going to end up starting with negation of A. So number 1 would be the negation of A, the reason it's given to you. 1, negation of A, is going to work with 2, A or D, also given to you. Well, now you've got enough information to use the disjunctive inference because you have a disjunction. Whoopsie, disjunctive inference from the first and second lines. And in this case, if it's A or D and not A is the case, then you know D must have happened. Then you're going to take a look at your next given, if T, then not D, given. And then by looking at lines 3 and 4, you can use your modus tollens. And your modus tollens says if your conclusion is false in one part and then that actual conclusion is true, like line 3 says, you're going to pull out not T. If T, then not D, D, not T. And 5 becomes modus tollens. There are some times when you can have more than one way to do proofs. The order doesn't necessarily have to be the same as mine, but you can't use a law of logic without having a whole bunch of givens or a few givens before that. It's got to make sense. Here's proof 2. In proof 2, I do see 2 conditionals, but I don't see the chain rule happening with them. So I'm going to work backwards from S to C to T to B to B. So I'm going to start off with that single letter B. That's given. And then I'm going to work with B, and my next given would be if B, then not T. That's given. And then I notice that my fronts are the same. So I'm just going to detach off the back. So my third line is not T, and that's because of detachment from 1 and 2. I'm going to go back to my givens, and I'm going to realize that T is being used in C or T, or excuse me, if C, then T. So I will use that conditional that was given to us. And then I can look at lines 3 and 4 and say, all right, well, I've got my back ends being opposite. I'm going to use my modus tollens. And I'm going to pull out a not C. and that's from lines 3 and 4. Nothing left to do. Go back to the givens. Here is a disjunction, and this disjunction is C or S, and that's given. And then finally, my proof statement is S, and I can actually pull that out, and I can from disjunctive inference. And disjunctive inference is from lines 5 and 6. Again, not much options in this particular proof with different ways that you can do it. The order can definitely be a little bit different, but you're pretty much stuck with some detachments, some modus tollens, and the disjunctive inference. Let's take a look at the next one. On this next one, I do see a chain rule that I could use, and I see it right off the bat. So I could go by chain rule here, or I could do it completely different. I am going to use the chain rule. There is another way to do this proof. Feel free to try to figure out the other way, but I'm going to go by chain rule. So I've got my line 1, if A then S, it's given, and my line 2, if S then N, given. So these are being used. And then my line 3, but the chain rule says if A then N from 1 and 2. We need to go back to my givens. Where else do I see it? Either the letter A or the letter N. It's going to be the single letter that you're going to have to use. So A is given to you. And now from 3 and 4, I can detach off of N. So this is detachment. And that's from 3 and 4. I'm going to go back to my givens, and I'm going to see that all that's left is negate W or negate N, and that is given. And then what I can do is I can use disjunctive inference, and I can say, well, if negate N and N are opposites, then I want negate W to be my true statement. So this would be now disjunctive inference. And that's from 5 and 6. So there's proof 3. Proof 4. On this one, I don't see anything with the chain rule. I do see a parentheses here, which seems a little bit strange, but it's just one piece, right? It's either if A, then parenthesis S or O. Don't let that mess you up. I'm going to start with that backwards game where I see an O, an O, an S to an A, an S to an S, and an A to an A. So it doesn't really matter where you start, but I think I'm going to go for that single A. So 1 is going to be A, 1 is given. Number 2 is going to be if A, then my parenthesis, and that's given. Well, my A's match up, so all we need to do is detach off the back. The back is that disjunction, no big deal. I lose the parentheses, you can keep them if you want, it doesn't really matter. Now with lines, oh nope, got to go back to my given, sorry. I need to now have my negate S, that's my given, so I can use that for my next line, given. So now from 3 and 4, I can use disjunctive inference, and we can pull out O, which is exactly what you wanted to prove. And we are now good. 3 and 4. All right, so that is it. Your homework is basically a little bit of the same. You're going to be using sentences and figuring out what law of logics are being used, and then you're going to be doing some proofs. Again, there might be more than one way to complete a proof. You only have to do it one way. It doesn't matter if you do it different from somebody else or different from me, as long as it's correct, all is well. All right, so good luck with the homework. Bye.